Okay, I want to talk just a little bit about chemical bonds. So first off, a chemical bond is simply a force that holds atoms together. Okay, and the reason a chemical bond forms is essentially to lower the potential energy of the atoms that are bonding together. So when they're separate, they're at a higher energy state than when they're bonded together. So it's favorable for them to form the bonds in order to lower their energy. Now, there's three different types of bonds that could be formed. So the first would be an ionic bond that typically forms between a metal and a nonmetal. What happens is the metal actually transfers electrons to the nonmetal. So really what happens is ions form, and then those ions are attracted by an electrostatic attraction between their charges. Um, and so you always end up having a cation from your metal and an anion from your nonmetal, and those positive and negative charges like to attract one another. Um, the next type of bond we can have is a covalent bond, and that's going to be between nonmetals, or most typically between nonmetals. And in a covalent bond, electrons are shared. And so these atoms come together, and neither wants to completely give up electrons to the other atom. And so what happens is they come together and they share those electrons. And so they share enough to where both are at a more stable arrangement, meaning that then they have a lower energy. And so it's better than when they're by themselves. And then the third type of bond we could have is a metallic bond, and that is between metals. And this is kind of the most unusual out of them, or kind of the hardest to understand. But in this type of bonding, your electrons are actually free flowing. And so you actually have lots of metal atoms all together, and none of them really want their extra valence electrons. And so what happens is they all have such a loose hold on them that the electrons can essentially flow through that structure. Now, most of the time, when you're just introduced to chemistry, you're talking about introductory chemistry topics or general chemistry topics. Usually, you would focus just on ionic bonds or just on covalent bonds. Just on those two. Metallic bonding is a little more complicated. It's a little more of a special area. So we're going to focus on ionic and covalent bonding. Now, it is good to have a general understanding of kind of the differences between ionic and covalent compounds, as a result of the differences in the types of bonding. So I've got this table here. It gives you a little bit of information about different characteristics of ionic versus covalent compounds. So in ionic compounds where you actually have this transfer of electrons in these ions, what happens is you have these huge lattices of cations and anions together. So it's not just a few atoms kind of bonded together in these individual molecules. You have a large lattice of cations and anions. So that actually makes these structures very strong. Okay. And so usually these interactions are so strong that these ions are bound together so tightly, they actually form a crystalline solid. Okay, so ionic compounds you would always assume are solids. The only way that they're going to be liquids is if you increase the temperature a lot. Um, and so these are going to be crystalline solids. Whereas covalent compounds, you have these atoms sharing electrons, but they form, small molecules. And so you have these individual units that, yes, in a sample you could have multiple of them, but those individual units, the way they interact, isn't as strong as the interaction between all of the ions in an ionic compound. So that means that when you have covalent compounds, you can have a whole variation of gases, liquids, and solids, depending on how strongly those individual molecules interact with one another. Um, Now, some other things, when they are solids, the ionic compounds are going to be typically very brittle and hard, whereas your covalent ones could be a brittle, hard solid, but they could also be soft solids, or waxy. Um, Another thing, if you want to compare like melting points and boiling points, ionic compounds, it's going to be much higher because their interactions between ions are much stronger. Whereas covalent compounds relative to ionic have low melting points and boiling points because again, you have interactions between these individual molecule units, which are going to be much weaker than the interactions between ions. Um, and with ionic compounds, since you have this whole lattice of charged things, they actually are really good conductors of electricity. They are also tend to be very soluble in water because, again, these charged species that are making up this whole lattice are going to want to interact with the polar water molecules. Whereas covalent compounds, you have these neutral units of things that, you may have this big cluster of all these neutral units, but again, they're neutral, so they're not going to conduct electricity very well, if at all, and they're not as soluble in water. That's going to depend on if they're polar or not. You've got lots of covalent compounds that aren't soluble in water, that are soluble in more nonpolar things, like carbon tetrachloride. So it's just going to depend on if that molecule is polar or not, because it definitely doesn't have a charge, because that would be part of an ionic compound.